Hello everyone. Today we are going to start another chapter of class 12, which is alcohol, phenol and ethers. Okay. So when we talk about alcohol, phenols and ether, alcohols first of all one by one we will see. So now we will see first alcohol, okay? So when we talk about alcohol, alcohol are the compounds that have one or more hydroxyl group, right? This one OH group, okay? One or more hydroxyl group, okay, bonded to aliphatic carbon atom, while phenol are the compound which have one or more OH group bonded to aryl carbon, or we can say aromatic ring, right? And these are obtained by how we can obtain this alcohol or ether or anything. So these are obtained by replacing one or more hydrogen atoms of aliphatic or aromatic hydrocarbons by hydroxyl group, right? So if we want to define this, how we can define alcohol or phenol, we can define like this: the compound obtained by replacing one hydrogen atom from an aliphatic hydrocarbon by hydroxyl group are alcohol, whereas those obtained by replacing hydrogen atom or aromatic hydrocarbons are phenols. Okay, so let me give you one example. Suppose we have here R and this is H. Okay, this is what alkene, right? Alkene. So this what we will do here, we will add here, we will subtract here hydrogen and we will add here OH. So what it will form, it will form alcohol, right? This one, okay, this is what alcohol. And again if we talk about the phenols, so we suppose this is a benzene here, okay. In this benzene what we will do, we will reduce one hydrogen and in place of that we will add one OH group here. So what it will form, it will form phenol, okay. So I hope you have understood this. Now we have got the basic idea of alcohol and phenol, right? Now, alcohol has many important applications in our day-to-day life, right? For example, you can take like this. We know ethanol, right? CH, C2H5OH, ethanol, OH, right? So when we talk about this ethanol simply it is called what, alcohol, and it has widely used as an important component of all alcoholic beverages, right? And as a solvent in many medicines also. Now, liquors as well as varnishes, there we are using this alcohol, okay. Now it is only used in the form of um, rectified spirits also for polishing wooden furnitures, and as an antiseptic also we are using this alcohol, okay. Now when we talk about the phenols are used for the manufacturing of dyes, okay, and resins, etc, okay. Or we can say in fact alcohol are very popular, used for the synthesis of other classes of organic compound such as alkanes, haloalkanes, ethers, aldehyde, ketones, acids, etc, right? Now as we know, we know that this the substitution of an hydrogen atom in an hydrocarbon by an alkoxide, that is RO, okay, or we can say aryl oxide group or ARO, this one alkoxide, this RO and this aryl oxy group, or you can say ARO group, right? So the substitution of hydrogen atom in the hydrocarbon by this and this, right, gives another class of compounds known as ethers. We will discuss about this in detail. So now there are also an important class of compounds, for example diethylene ether, which has been extensively used in the industrial solvent. Okay, so I hope you have got some idea about the alcohol, phenols and esters, right? So now one by one we will see this. So first of all is classification of alcohols. Okay, so now, so this was, there is some general idea as you can see here, right? Now we will jump to the next slide. Okay, now classification here. So when we talk about the classification of alcohol here, as you can see, classification of alcohol. So the classification of alcohol is carried out by three types depending upon the carbon which has been attached to the hydroxyl group in the structure of alcohol, right? So alcohol are, or we can say, what we can tell here, that alcohol are the compounds containing hydroxyl group, that is OH group, attached to the alkyl group, right? Therefore these are regarded as what, hydroxy derivatives of hydrocarbons, and are also called aliphatic alcohol. Okay, so when we talk about the classification of alcohol, it is generally carried out by three process, as you can see: primary, secondary and tertiary. Okay, or we can say 1 degree, 2 degree or 3 degree alcohol. So how to identify which one is 1 degree, 2 degree or 3 degree alcohol? There's a very simple method. So if the carbon atom this uh, through which this OH group is attached, if the carbon, suppose this is the carbon right here, and through this carbon this OH has been attached, so you have to see if this carbon is 1 degree, then the alcohol will be 1 degree alcohol or primary alcohol. Okay, now next is, if the carbon is attached to two other carbons, so at that time it will be 2 degree. Let me, as you can see here, this is called what, 2 degree carbon or secondary alcohol. As you can see, this carbon is here, is was 2 degree, right? So that since this carbon is 2 degree here, and the carbon to which this OH is attached is will be, the OH is attached to this 2 degree carbon, right? So that is why it is called secondary alcohol. Okay, now next is tertiary alcohol. So when we talk about the tertiary alcohol, you see this carbon is what, this is 3 degree carbon, right? So since from this 3 degree carbon this OH is attached, so it is called what, tertiary alcohol. Okay, so I hope you have understood about 1 degree, 2 degree and 3 degree carbon atom. Now when we talk about the uh, nature, or we can say that when we talk about the one more class is there. Let me see here if it is given. No, now let me tell you. So we have got here 1 degree, 2 degree and 3 degree carbon. One more class is there which is called classification based on the OH group. Okay, so when we talk about the classification based on OH group, there are basically four type of alcohol. Okay, one is monohydric. Okay, another one is dihydric, third one is trihydric, and fourth one is polyhydric. Okay, so how we will identify which one is monohydric or which one is dihydric? So if from, suppose this is compound CH3OH, as you can see in this CH3 only one OH is there, right? So it means it is monohydric alcohol. Okay, suppose if there is like this CH2 and here also one OH and here also one OH, means here two OH is there, right? So it will be what, dihydric. I hope you are understanding this. Okay, now next is, if there are three like this, if there are three CH2OH, again CH2 OH, and here again CH2 OH, means three alcohols are, OH group are attached here, right? So it will be what? Trihydric. Okay. Now next, when we talk about the polyhydric means the starch and cellulose, means here so many more than three OH groups are attached in this structure when you will see. So that is why they are called what? Polyhydric alcohol. Okay. Now next is one more uh, classification is there. We can tell like this: the classification based on, or we can say that allylic, or we can say that allylic alcohol. Okay. So what is this allylic alcohol? ALLYLIC. Okay. ALLYLIC. So what is this allylic alcohol? I will tell you. In this alcohol, the hydroxyl group is attached to sp3 hybridized carbon. Okay. I hope you know what is hybridization, right? So in this alcohol, when we talk about the allylic alcohol, in this alcohol, the hydroxyl group is attached to sp3 hybrid carbon. Okay, next to the carbon carbon double bond known as allylic carbon. Okay, and this alcohol can also be classified as primary, secondary, or tertiary allylic alcohol. I will give you one example. So this is the example of, suppose this one is like this, here OH is there. So this is the example of 1 degree allylic alcohol. Okay. Now next, because here this position where the OH is attached is sp3. Okay, and next to that there is a double bond, right? As you can see, what I have told, in this alcohol the hydroxyl group is attached, group is attached to a sp3 hybridized carbon. This carbon is sp3 hybridized, right? And through this carbon this OH has been attached. Now next carbon next to the carbon carbon double bond is what? Allylic carbon, as you can see here. So this is 1 degree allylic alcohol. Now next, when we talk about this, you will see like this, here here OH is there. So this one is what? This is 2 degree allylic alcohol. Okay. Now again, when we talk about the 3 degree, so it may be like this. You can take the example here, OH. So this one is what? This is 3 degree allylic carbon. Okay, allylic alcohol. So I hope you have understood this, right? Now next is classification, or we can say compound containing carbon, and like this, carbon will be sp2 and through that OH will be attached, like this, carbon will be sp2. Okay, and through that OH will be attached. Okay, so in this type there is only one type, which is called vinylic alcohol. Okay, so what is vinylic alcohol? This contain what? OH group attached to the carbon atom of a carbon carbon double bond. Okay, carbon carbon double bond, and this alcohol are called what? Vinylic alcohol. I will give you one example. So this type, CH2 double bond CS, to which OH is attached. So this is what? This is vinylic alcohol. Okay, now I hope you have understood this. Now next we will see nature of alcohol. When we talk about the nature of alcohol, so at that time we have to see, suppose I will give you one example. Let me tell you, let me give you the example. Suppose we have this O, and here H, and here CH2 CH3, right? So at that time dipole moment will be where? For this dipole moment will be here. For this the dipole moment will be here, and overall dipole moment will be like this, right? So when we will count the dipole moment of this, it will be like this: mu is equal to 1.3 0.69 dB. Okay, so this is what here, this is called ethanol. Okay, and its boiling point will be 73 degrees Celsius. Okay, now in place of this, if you are taking dimethyl ether, so its dipole moment will be 1.30 dB, and at that time the boiling point will decrease. Okay, it will be 23 degrees Celsius. Okay, now again, in the, if in that place, if you are using propane, at that time it will its dipole moment will be almost zero, so at that time its boiling point will be 42 degrees Celsius. Okay, now one more thing, always remember that if there is one alcohol, if there is an alcohol, okay, like this, R O and H, and here it is double bond and lone pair. So at that time, if we are taking here, suppose if we are taking here water, okay, so at that time what will happen, this lone pair will transfer to this. Okay, and at that time it will form what, alkoxide ion. Okay, it will form alkoxide ion like this, right, and plus this will be like this. Okay, like this. Okay, I hope you have understood this. Now next is what, when we talk about the acidic nature of alcohol, at that time, or we can say the acidic nature or relative acidity or relative basicity, at that time always remember that this H2O will be more acidic than OH, ROH, after that RC double bond CH. Okay, that will be more acidic than N2, that will be more acidic than NH3 and RH, right? So this is what, this is an as relative acidity. Okay, now when we talk about the relative basicity, at that time there will be a reverse. Okay, at that time R will be more, after that NH2 negative, after that H negative, after that RC double bond C negative, like this, after that RO negative, and then HO negative. Okay, so this is a what, this is a basicity or relative acidity or basicity. When you will see the pKa value of CH3OH, it is around 15.5, right? And when we talk about the pKa value of H2O, it is about 15.74 something, right? So this was some idea about the nature of alcohol. Okay, now next is what, nomenclature. Okay, you will see here nomenclature is I think here it is not given, so we will see from here only. So when we talk about the nomenclature or IUPAC system or of nomenclature, IUPAC system of nomenclature, so at that time what we have to do, some rules we have to follow. Okay, and what is that rule? That rule is, according to the IUPAC nomenclature, alcohol are named by replacing this one with OL, right? Okay, so what we can write, alkene minus E plus OL, it will be ALK ANOL, alcohol, right? Now what is this system when we talk about the nomenclature? So at that time what we have to follow, the rule is same as we have done so many nomenclature, right? So the rule is same. Rule is what, the longest continuous chain containing the carbon bonded to OH group is selected as a parent chain. Okay, same thing. Now next rule is what, the carbon atom in the chain are numbered in such a way that the carbon atom carrying a hydroxyl group, that is OH group, gets the lowest number. Okay, now third is rule is what? The position of the substituents is indicated by a suitable number. So let us do two example, one or two examples related to the nomenclature. So let me give you one example. Suppose we have this. Okay, here OH is attached here, and here one. So how will we how we have to what we have to do? We have to give the functional group as a lowest number, right? So our numbering will be from here, right? 1 2 3 4 and 5. So what will be the name of this compound? The name of this compound will be what? It will be 2 and 4 here, right? So 2 4, okay, dimethyl, okay, how many carbon? 1 2 3 4 5 pentane, and OH is on the first, right? So 1 OL, right? So I hope you have understood this. So how we have to number into this, right? How you have to how we have to number this, right? Now next is this one. Suppose here, let me try again here. Here suppose it is C6H5, okay, and here is suppose OH is there. So how we will give the number? We will give the number to this functional group. The lowest number should be functional group. So it will be 1 2 3 4 and 5, right? So what will be the name of this compound? The name will be, first of all, what we have to give? We have to choose this. So 4 phenyl pentane, OH is in the second position, so we will give 2OL, right? So I hope you are understanding this. Now next is, suppose it is like this. Like this, and here OH is there, here is OH. So at that time, how we will give the number? Suppose this is 1, this will be 2 3 4 and 5, right? So how many carbon? 5 carbon means pent, okay. After that, in which position double bond is there? In the fourth position, so we will give here 4 ENE, okay. And in the second position there is OH, right? In the second position OH is there, so at that time we will write 2OL. I hope you are understanding this, how we have to name this compound, okay. Now next is, suppose this, here it is double bond, okay, this is we have done. Now next is, suppose like this, and here is double bond. So at that time, if suppose OH is this, so at that time how we will name? This one is 1, this one will be 2 3 4 and 5, right? So how we will write? We have to give here, at that time we have to write like this, trans, this is trans, right? Trans, how many carbon? 5 carbon, means pent, in the second position there is pent, right? 2 in the second position double bond is there, right? So we'll write 2 in, and in the first position alcohol is there, means 1 OL. I hope you are understanding this. Now we will see one more example here. Suppose we have like this. Here is suppose CH3, and here is OH, right? So at the time, what will be the number? We will give to this one, we will give this 2 3 4 5, right? So how we will name? We will write here 2 2 methyl, okay, cyclo, 5 carbon is there, right? So pentane, ol, okay, or 1 ol, anything you can write, right? So I hope you have got some idea how to write this. Okay, now again, if in some question you will see like this, suppose we have this, like this is there, OH group is here, and from here this is double bond here, Cl is here hydrogen, and here also hydrogen. So at that time, how we will give the number? Suppose here is CS3, so we will give the number to this one, this one will be 1 2 3 4, like this. Okay, so at that time when we will number this, we will give here Z, you know, Z naming, so it will be Z 4 chloro but 3 en 2 ol. Okay, so I hope you have understood this, how we have to number this. Okay, so this was about the nomenclature of or we can also, one more example I will give for polyhydric alcohol. Suppose we have like this, OH CH2 OH. So at that time, what we will write, what will be the name of this? It is what? Ethylene glycol, right? This one is what? Ethylene glycol, right? Now one more example, if you will see, CH3 CH CH3 CH CH2, and suppose here is OH and here is also OH. So at that time, what will be the name here? Polyethylene glycol, right? So we can number and we can name this, name it like this also. One more example I would like to give you. Suppose we have HO, here it is CH2 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 OH. So at that time, what will be the name of this compound? The compound name will be trimethylene glycol, right, or beta glycol, right? Name will be trimethylene glycol, or we can also write this is what? Beta glycol. So I hope you have understood how to name, how we have to name the alcohol, right? Now next is physical properties. So when we talk about the physical property, we will see here physical properties, as it is also written here. You can read it from here, it will be available in the notes. So I will give you some of the basic points. In alcoholic compound, as you can see, in the alcoholic compound, electronegativity of oxygen is 3.5 of the hydroxide group is higher than the electronegativity of the hydrogen, which is 2H group. And due to what? Due to this partial negative charge of OH, partial negative charge of positive charge on hydrogen, there is this like this. So delta positive and delta negative bond become polar, and the liquid alcohol intermolecular hydrogen bond is formed. Okay, so these are some of the physical properties. It is given here, as you can see, right? So as you can see here, acidity also it has been given here, acidity and basicity of alcohol. As you can see, aqueous solution, as you can see, aqueous solution of when we talk about the acidity of alcohol, so let me explain you. Aqueous solution of alcohol possess slightly acidic property due to the polar OH bond present in them. Okay, and alcohol give acidic property similar to the water, and most of the alcohol except methanol is less acidic than water, as you can see here, and we have also discussed about this, right? Now In alcoholic compound, as you can see, the in alcoholic compound, the electron releasing group, which is this RCH3 or RC2H5, increases the electron density of OH bond, so result in the decrease in the polarity of the OH bond. As a result of the act, property is decreasing, acidity property is decreases. Okay, and as you can see, the order I have also given you, and this one you can take the another one. Okay, the first order, order time I have given you the order, right? So what was the order? Acidic order, this was the order, right? When we talk about, it will be H2O, after that ROH, right? This one I have given, right? R C double bond CH, after that it will be N2, N2, after that NH3, NH3, and after that RH. Okay, so this was some of the basic things or introduction about the alcohol and classification of alcohol. I hope this class you have understood, right? So now in the next class we will discuss about the properties or preparation of alcohol, right? Till that, you try to practice the nomenclature, okay, and according to the new system, okay, and you try to refer the new book, or the book in which the nomenclature is given in a new form, okay, not in the old form. So if you try to do that, the nomenclature, okay. Till that, thank you.